What is X-ray diffraction, XRD, and how does it work to study the properties of materials, such as lattice parameters, atomic occupancy, symmetry, and crystallinity? Why is XRD considered the most common and effective technique for determining the composition and structure of materials? How do X-rays interact with a crystal when irradiating it, and how do these interactions lead to scattering by the lattice points? In what way do the scattered waves combine or cancel out in space, and how does this phenomenon result in a diffraction pattern? How does the Bragg equation play a key role in determining when diffraction occurs, and what is its significance in ensuring that X-rays are reflected at certain angles? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? What does it mean for a lattice surface to satisfy the Bragg equation, and how does this condition influence the diffraction process? How does the diffraction result depend on the specific wavelength of the incident X-rays and the angle of reflection, and what does this reveal about the material's structural properties? Why is it important to understand the concept of coherent superposition or cancellation of waves in the diffraction process, and how does this relate to the overall analysis of material structure? How does XRD provide detailed information about the lattice stress, heterogeneous structures, and defects in a material, and how does this help in the characterization of electrode materials for sodium-ion batteries? What is the significance of lambda in X-ray diffraction, and how does it relate to the wavelength of the incident X-rays? How does D represent the lattice plane layer spacing, and why is this an important factor in understanding the diffraction pattern? What does theta represent in the context of X-ray diffraction, and how does it affect the diffraction angle between the X-rays and the lattice plane? How does the relationship between lambda, D, and theta help in determining key structural characteristics of materials during X-ray diffraction analysis? What is Scherer's formula, and how does it contribute to estimating the grain size of the material particles? How does Scherer's formula combine the diffraction data to provide insights into the material's particle size, and why is this estimation important for understanding the properties of materials? How does the grain size relate to the overall structure and performance of materials, particularly in the context of electrode materials for sodium-ion batteries? Why is it crucial to integrate both X-ray diffraction data and Scherer's formula when analyzing the material's structural properties, and how does this dual approach enhance the accuracy of the characterization process? What does the variable D represent in the context of X-ray diffraction, and how is it related to the grain size of the material being analyzed?